this is the continuation of the previous video. So I already explained this Pearson correlation R value, so this formula, but I did not show you how to calculate this R value for a given data set. Okay, so I'm going to show you how to calculate this R for a given data set. So let me pick a very simple data set. Okay, so let me pick the same example, sort of like say y is the resale values of used cars in $1,000. Okay, so x is the age of the car, so in either maybe in number of years, how many years old or whatever that, or the mileage in terms of 10,000 or something. Okay, so whatever the unit. Okay, so anyway, so these are the y values and the x values. So now, so I want to calculate this. Okay, so first of all, you need to figure out the x bar, the sample mean, sample standard deviation for the x values, the same thing for the y values. Okay, so the n is the number of data points, number of pairs. Okay, so the number of data points means that the number of, like, this is one pair actually. When x equal 1, value of y equal that, like that. So the number of data n equal 5. Okay, the number of the pairs basically. Okay, it's 5, and so for this value you need to punch these values into the your calculator memory and figure out the x bar, which is 2.8, and figure out the sample standard deviation is going to be 1.643, and then clear the memory and punch these values into the memory and figure out the average, which is 20. Average of these is 20, and the sample standard deviation is going to be 7.91. Okay, and once you get those values, so see here, we want to figure out this. Okay, the summation, this is the sigma notation. Summation, sum goes over each data point, each data point. Okay, so the summation goes over each data point. This is that I, the I thing. Okay, right there. So here, for each data point, you need to minus the mean divided by the standard deviation for x values. For the x values, 1 minus the mean, this 1 minus the mean divided by the standard deviation, which is that. Do the same thing for the y value. 30 minus the mean, 20, divided by the standard deviation, 7.91. So that product is that for that data point. Okay, for the first one. So that you need to, for each data point, you need to calculate that and need to add them up. The summation goes over I, right there. Okay, so for the first data point is that, the second data point do the same thing, third, fourth, like that. The fifth data point, which is 5 minus 2.8, the x bar, divided by the standard deviation, which is that. This is for the this one, and the 10 minus y bar divided by the sy, the standard deviation for the y values, that. So for this whole thing is that. So for each data point you have values like that, 5 values, this value, this value, this value, like that, 5 values. So you need to add them up, all those 5 values. Okay, add them up, that will give you this sum, this part, and you need to divide that thing by n minus 1, the sample size minus 1. Okay, the sample size is 5. Okay, sample size is, this is 5 minus 1, 4. So once you add them up, divided by 4 will give you the R. So add them up, divided by 4 will give you that value, R value. Okay, so the R value is going to be, this R Pearson's correlation is going to be minus 0.962. See now, it has a negative value, which means has the negative trend. Okay, you remember that when the age goes high, the price goes down, right? So it's a negative trend. It's reflect with that R, and the way I put the data is they're very. If you graph it, this is the scatter plot for this data. Okay, so the x-axis and the y-axis. The y values I put it this way, and here that scatter plot. See, they're very close to a sort of a straight line, like that. Okay, but they're not perfect. They're not fit onto perfectly on a straight line. If they're perfectly on a straight line, this would be -1. Okay, so there's a very strong linear correlation for this data set, for these x values and the y values. Okay, so so anyway, this is how you calculate your R. So if you are using a software, you don't of course have to do this. All you do is that you put these values and these values, and then ask the computer to do it, and then it will give you immediately this, and along with many other things. Okay, so anyway, this is how if you have to use a calculator. So later I will give you another way to calculate this R value rather than calculating it like that. Okay, another way to do that. And also later you will see this thing. If you take the square of that R square, you're going to get square of this value is going to be 0.926. Later you will see that this is the idea. Later I will get into that. So whenever that means that sort of, so using this x variable, you can explain 92.6% of the variability of these y values. So in other words, the idea is this actually. You're trying to use this x value, the age, to model the y. Okay, so in other words, if you take a 2-year-old car, you're not going to get one value. You will get a whole bunch of range actually for 2-year-old cars. But in other words, if you collect a lot of data, so for 2-year-old car, there would be a whole lot of data points for 2 years. But sort of the idea is that there's a downward trend. Okay, but for the data set I gave only 5 data points anyway. So see, even the 2-year-old car, there are 2 cars with the 2-year-old cars. Okay, 2 cars, so they have 2 different values. Okay, so anyway, that. So for this particular data, you can explain 92.6% of the variability with respect to this using x variable, using the age basically. Okay, so anyway, so that's how to calculate the R. Okay, all right. So in the next, what we are going to get into next is this. We are going to fit a straight line for that. Say in other words, you already know that this is almost like that, a straight line. So what we are going to do is that, if I have a line like that, what kind of this A value and B value will be very closest to this kind of, say if you have to make an eyeball fit, I have to draw a line like that. That kind of thing is known as an eyeball fit. You kind of look at it and then guess it. Okay? But if you draw like that. But we are going to do it in a formal way by minimizing something, some sort of distances. Okay? So we'll show you how to get that, how to get an estimated line for this kind of data. So the idea is that once you know that if that's going to fit a straight line, if that's going to show a straight line, we're going to fit a straight line and estimate these parameters, these things. Okay, these things. Okay, that's coming up next. Okay, all right, let me stop here.